we are given a cylindrical container, and they are telling us that the volume has to be, they say 343 cubic centimeters. Okay, what dimensions, radius and height, will minimize the surface area? Perfect. So minimize surface area. It says that, and this is very important, let's go back for a second. It says an open top. So we will not consider the area of the top because it's open. It's a cylindrical container, of course, it has to have a bottom, which is a circle. It's to have a volume of this, what dimensions, radius, and height will minimize the surface area. Awesome. Perfect. So we have to give them some names, right? So I'm gonna call this R, the radius, and I'm going to call this height, H. Now, I'm gonna reach in my recycling bin and pull out one of the papers that we just went through or over. So here it is. See, this is, imagine, I know it's not, but please imagine that this is a cylinder, right? This is a cylinder. And just imagine that it has a bottom. It doesn't have a top, but it has a bottom. Okay, so the reason I'm talking about all this is because we have to find a function that represents the surface area. Okay, so the surface, S. Okay, so this is the cylinder, and the surface area is all around it, including the base. So I know that the base, the area of the base, anybody remembers the area of a circle with a radius R? Anyone, please? The area of a circle. Okay, so that is pi r squared. Okay, perfect. So now I have to add all around. So look what happens when I do this. So what happens is, this is the surface area, and the base is the circumference of the cylinder, of the base of the circle, of the circle of the base, and all this is the height. How do I determine this area? Well, this is a rectangle. So the area of this rectangle is base times height. So the surface will be, first of all, pi r squared plus this area, the circumference times the height. Anyone remembers the circumference of a circle? So this was the area of the circle, but now we want the circumference because it's the all around times the height. That will be 2 pi r multiplied by the height. So this is the function that we have to minimize. In other words, we have to find its minimum. Okay, now I have a problem here. Can anyone tell us what is the problem here? When you look at this function, what do you say? Oh, there is a problem. What is the problem? Pi. Two variables. Pi is a poor number. Pi is a poor number, 3.14. Nobody cares about pi because, say it again.
Would it be height and radius?
Yes, the fact that I have two variables. I have r and I have h. That is the problem. Good, but I do know the volume. I am given the volume. The volume is specifically given so I can get rid of one of these two. Because I cannot minimize, we will in chapter 6. We will be able in chapter 6 to find the minimum of a function with two variables, but not today. We have to wait till chapter 6. But this function has two variables. At this point, we don't know how to find the minimum of a function with two variables. But this is the reason why the volume is given to us. So the volume of a cylinder is area of the base times the height. So pi r squared times the height. And we are given that this has to be 343. So 343 equals pi r squared h. From here, we will solve either for h, it's up to you, or for r. And plug it in here so we have s as a function of one variable. The easiest thing to do is solve for h, because I only have one spot where I have to replace it. If you want to solve for r, then you will have two different places to replace. But if you want to get rid of h, let's solve for h. Can anyone tell us what does h equal to from this equation? And this is algebra. This is not calculus. How do I solve this equation for h? Anyone, please?
We did 348 divided by 9.
By pi r squared, yeah, of course. That's exactly what it is. So 343 divided by pi r squared. I will plug this in here. Now s is indeed a function of one variable only. We have pi r squared plus 2 pi r times this. 343 over pi r squared. Yes, we're going to simplify one of these numbers. We're going to simplify an r. So then s of r equals pi r squared plus 2 times this is 686 over r. Okay, one more time. So we had 2 pi r, and we replaced h by 343 over pi r squared. The pi's go away, one of the r's go away. I have to multiply 2 by 343 and divide by r. This is the function that they're asking us to find the minimum for. So we needed some steps to get to it. It was not given to us. Okay, now, what is the first step? What is the second step? What do I need to do to find the minimum or the maximum of this function? First step. Of course. Of course. That is mandatory. That's what we studied in this chapter all over, all the time. That's it. So s prime of r. Can anyone help with any of this? Differentiating that or differentiating this or both?
I would go away with just use as r, right?
So when we
Oh, I'm
differentiate,
sorry, 2r.
you mean 2 pi r. This is a number. We cannot change it. So we bring down 2. 2 pi r. Good. Awesome. Now we want to differentiate this. And we have a formula for differentiating 1 over r. We discussed it last time, and we discussed it many times before. When we differentiate 1 over r, what do we get?
Minus 686.
Yeah. Very good. Yes. Excellent. Thank you. Very good. Now we have to find the least common denominator. Luckily, it's only one denominator. So, but I need to multiply this by r squared. So I get 2 pi r cubed minus 686. Okay. Finally, I have the simplified form of the derivative. What is my next step? I found the derivative. Yay! What do I do with it? Why am I even finding the derivative?
Set it equal to 0.
Yes, we set it equal to 0 or to undefined to find critical numbers. Oh, this is not good anymore. So there is nothing coming from this because you can say, but r can be 0. True, But if r is 0, there is no cylinder. So S does not exist at 0. So S prime being undefined, yes, but the function doesn't exist at 0, so no. So when we set a fraction equal to 0, what happens? What do we need to do? How do I solve this fraction equal to 0? When is a fraction 0?
When the numerator.
Excellent. Only when the numerator, 2 pi r cubed minus 686 equals 0. I move this and divide by 2. So pi r cubed equals 343. I also divide by pi. R cubed, 343 over pi. What do I have to do to both sides to get r? And I will approximate it. And I'm afraid to show the software, so I'm going to use my calculator. No, I'm kidding. I'm not afraid to show the software for this calculation. So, what should I do to both sides, first of all, to get r by itself?
Do we cube it?
Yes, the cube root, the inverse operation. So this is the cube root of 343 over pi. So I have the silly thing up. Okay. So we have, the way I like it, it's this, but you can do other things that you prefer. I prefer this. Caret to power 1/3. There are other methods. You can go to math and take the cube root. I prefer power 1/3 because I know the cube root is power 1/3. So I got 4.78. So r equals 4.78. Now we have to look at the measurement unit. Is this going to give a minimum surface area? I have no clue. But I learned in calculus that this is very easy to figure out. By studying the sign of this, not this, because this is always positive. I will not waste my time with r squared. So in this piece, I will plug in 0 to the left of the critical number. And when I plug in 0, what sign do I get? When I plug in 0? Negative. Excellent. Now I'm going to put in, let's say, 100. I'm not going to put it in the table, but I imagine. 100 cubed is 1,000. Times 2 will be 2,000. Times 3, way more. It will cover up this. So now I know that this is typical situation for a minimum. What is the minimum? Because they're asking us to find not just the area, the radius and the height. I didn't find the height yet, so I have to find the height. 343 divided by pi r squared. So let's do that right now because they're asking us. And here's how I like to do it. So I have 343 divided by, in parentheses, pi, because there is a pi in there, times the previous answer squared. I don't want to plug in anything. I'm just going to put the previous answer, and I'm going to square it. Because it is the previous answer. It's not 3 calculations above, right? So you can do this, because it's right here. This is the number you want. So 343 divided by pi, previous answer squared, and this is the height of the, oh, okay, very possible. So the height is the same number. That's fine. Centimeters. Okay, now we want to plug this in, the function. So where is r? S of r. So I have pi r squared. Now I have I can, because it's the same with r, I can square it. I'm gonna say the previous answer squared. And then plus 686 divided by the previous answer. In this way, by not entering a rounded up number, I get the best answer. So 215.30. .30, and this is surface area, this is distance, volume is cubic centimeters, and this must be squared centimeters. And this is the minimum surface area, given the conditions we had, and the restrictions, if you want, we had. Any questions on this problem? Is this better? Do we feel better about it?
Not really, but I think we probably should just move on because it's 7:30. I think I'll have to talk to you more later. It's just a lot.
Which part do you think was not very clear?
I don't know. I think I'm just not a mather. It's just hard. It's hard for me to grasp it, I guess.
Uh,
I understand the derivative
but not this part, right?
Yeah, I understand the table, what we've been doing. I get that part. I think maybe it's just a lot, but I understand how to find the derivative and the minimum and the maximum.
Okay, that is the best thing. That is the most important part of this course. Okay. If you have other questions, please bring them to class. Okay, let's move on back to implicit differentiation. So back to 3.8. And I am going to go directly to, where's my book? I did not open the book. Oh, maybe I did, but where is my book? Right here. Yes. Okay, so we would like to practice. Anything you'd like to look at on page 359. Any problem from 1 through, let's say, 33, let's choose. 1 through 14 is just asking us to find dy over dx, which means y is a function of x. The rest, I should say, between 15 and 28, they have two questions in there. One question is, the first question is find dy over dx, and the second question, so this is a little bit more complex than this. The second question is also find the value of dy over dx at the given point. So let's choose a problem from these and determine